The morning of June 30, 1908, dawned like any other in the vast, emerald wilderness of the central Siberian plateau. In the remote settlement of Vanavara, a small trading post nestled by the Podkamennaya Tunguska River, the air was crisp and smelled of damp pine and wood smoke. The Evenki people, the indigenous nomadic reindeer herders of the region, were beginning their daily rituals, unaware that the world, and the very fabric of the sky, was about to undergo a violent transformation. Semyon Semyonov, a local farmer sitting on his porch, watched the horizon. To him, the taiga was a constant, a sprawling ocean of larch and birch that stretched into infinity. But at approximately 7:17 a.m., the constant vanished. The atmosphere didn't just change, it tore open. A streak of light, brighter than the sun and trailing a column of dust like a scar across the blue vault of heaven, plummeted from the southeast. It was a bolide, a massive fragment of a comet or asteroid, plunging through the Earth's protective envelope at speeds exceeding 15 kilometers per second. For the few witnesses scattered across the sparsely populated wilderness, it was as if a second sun had been born, one that moved with terrifying, predatory intent. As the object descended, the friction between its mass and the thickening air generated temperatures reaching thousands of degrees Celsius. The pressure built up until the structural integrity of the celestial visitor could no longer hold. At an altitude of about 5 to 10 kilometers above the Earth's surface, the kinetic energy was released in a single, catastrophic airburst. The energy unleashed was staggering, estimated today at 10 to 15 megatons of TNT, roughly 1,000 times more powerful than the atomic bomb dropped on Hiroshima. In Vanavara, 65 kilometers away from the epicenter, Semyonov felt the heat first. He later recounted that the sky seemed to split in two, and the heat so intense surged across his skin that he felt his clothes were catching fire. He was thrown from his porch, losing consciousness as a wall of air hammered the settlement. Windows shattered, chimneys crumbled, and the ground groaned under a seismic shockwave that would be recorded by barographs as far away as London and Washington, D.C. Deep in the forest, the impact on the environment was apocalyptic. The thermal radiation ignited a massive, flash fire, that scorched the bark of trees for miles. Then came the blast wave. Moving at supersonic speeds, the wall of compressed air slammed into the forest floor. In an instant, 80 million trees were snapped like toothpicks, laid out in a radial pattern pointing away from the center of the blast. Among the Evenki herders closer to the ground zero, the experience was one of pure, mythological terror. Reindeer were incinerated or blown away, teepees, chums, were lifted into the sky. To the survivors, it felt as though the god Agda, the god of thunder, had descended to punish the earth with fire and iron. As the initial roar faded, it was replaced by a haunting, heavy silence, broken only by the crackling of 1,000 fires and the eerie, midnight bright glow that would persist in the night skies across Europe and Asia for days to come. The Tunguska event had occurred, but because of the region's extreme isolation, the world outside would not truly understand what had happened for decades. The great silence of the Siberian taiga had swallowed the evidence of a cosmic hit and run, leaving only a wasteland of charred wood and a mystery that would baffle science for over a century. In the days following the cataclysm, the world experienced a phenomenon that felt more like folklore than physics. In London, Stockholm, and Berlin, citizens stepped out of their homes at midnight to find they could read the newspaper by a strange, ethereal light. The sky was not black, but a haunting shade of silvery pink and gold. High-altitude dust from the explosion was reflecting sunlight long after the sun had dipped below the horizon. Scientists at the time theorized it might be volcanic dust or ice crystals, but the true source, a scorched scar in the heart of the Siberian wilderness, remained a secret held by the taiga. Inside Russia, the political climate was as volatile as the Tunguska sky. The 1905 revolution had left the Tsarist autocracy fragile, and the vastness of the empire made communication with the interior agonizingly slow. Reports from the Trans-Siberian Railway filtered into newspapers in Irkutsk, describing a pillar of fire and earth tremors that derailed trains. Yet, to the academic elite in St. Petersburg, these were dismissed as exaggerated tales from the wild East. For the Evenki survivors, the aftermath was a landscape of ghosts. Those who dared to return to the site of the fire from heaven found a scene that defied natural law. At the very center of the destruction, there was a stand of trees that remained upright, but they were stripped of their branches and bark, standing like a forest of telephone poles. Beyond this telegraph forest, millions of trees lay flat in a perfect, symmetrical butterfly pattern. The local population believed the area was cursed. They spoke of the Valley of the Great Fire, and warned that the ground itself was angry. This cultural taboo, combined with the extreme geographic isolation, accessible only by treacherous river routes and boggy marshes, meant that no scientific expedition would reach the site for nearly 20 years. The man who would finally break this silence was Leonid Kulik. A mineralogist with a passion for meteorites, Kulik was a man of iron will and obsessive curiosity. In the early 1920s, while working for the Soviet Academy of Sciences, he stumbled upon old newspaper clippings from 1908. He became convinced that a massive iron meteorite, a treasure trove of scientific data and perhaps valuable nickel, lay buried in the Siberian mud. In 1921, Kulik led a preliminary scouting mission, but the harsh conditions forced him to turn back. It wasn't until 1927 that he finally secured the funding and supplies for a full-scale expedition. He believed he was looking for a crater, a giant hole in the earth similar to the Barringer crater in Arizona. The journey was grueling. Kulik and his team traveled by horse and sled, then by riverboats, and finally on foot, hacking through dense undergrowth and battling swarms of mosquitoes that plagued the Siberian summer. When they finally broke through the tree line into the zone of destruction, the sight was haunting. Kulik stood on a ridge and looked out over a graveyard of giants. For as far as his binoculars could see, the ancient larch trees were laid out in neat rows, all pointing away from a central point, as if pushed by the hand of a god. But as he descended into the center, expecting to find a gaping maw in the earth, he found something much more confusing. There was no crater. There was no giant iron rock. There was only a swampy, peat-filled basin and the telegraph trees standing defiantly in the middle of a wasteland. The lack of a hole didn't make sense to 1920s science. If something hit the earth with the force of 1,000 suns, where was the scar? Kulik's obsession only deepened. He spent the following years returning to the site, draining bogs and digging into the permafrost, desperate to find a fragment of the visitor. He was looking for a physical body, but he was standing in the middle of a ghost, the remains of an explosion that had occurred entirely in the air. Leonid Kulik's 1927 discovery had turned a local Siberian legend into an international scientific enigma. However, the lack of a crater was a devastating blow to his theories. In the scientific community of the 1920s and 30s, an impact without a hole was a paradox. Kulik remained undeterred, fueled by a Soviet drive for industrial and scientific triumph. He returned in 1928, 1929, and 1930, bringing with him heavy equipment, drilling rigs, and a crew of laborers to probe the southern swamp, the area he believed hid the celestial intruder. The conditions were nightmarish. The crew lived in makeshift wooden huts, battling scurvy, extreme cold in the winters, and the Siberian plague, anthrax, that occasionally swept through the reindeer populations. Kulik was a taskmaster, driven by the belief that a massive nickel-iron meteorite was buried just beneath the peat. He ordered the manual draining of several circular bogs, which he mistook for small impact craters. After months of backbreaking labor, the results were heartbreaking. The craters turned out to be pingos, natural depressions formed by the freezing and thawing of permafrost. There was no iron. There were no giant fragments. There was only the haunting silence of the flattened forest. As the 1930s progressed, the world's attention shifted toward the gathering clouds of World War II. Kulik's funding began to dry up. Yet, his work had laid the crucial foundation for what we now call planetary defense. He was the first to realize that the devastation was radial, and he meticulously mapped the orientation of the fallen trees. This butterfly map would later become the key to unlocking the physics of the blast. Kulik's personal story ended in tragedy. When Germany invaded the Soviet Union in 1941, the aging scientist traded his magnifying glass for a rifle. He joined the People's Militia to defend Moscow, was wounded, captured, and eventually died of typhus in a prisoner-of-war camp in 1922. He never found his meteorite, but he had opened a door that could never be closed. After the war, a new variable entered the equation, the atomic bomb. When Soviet scientists saw the footage of Hiroshima and Nagasaki, they noticed a chilling similarity. In the hypocenter of the nuclear blasts, directly beneath the point of detonation, some trees and poles remained standing upright while everything around them was leveled. They looked exactly like the telegraph trees Kulik had photographed in the center of the Tunguska site. This led to a radical shift in thinking. The Tunguska event wasn't a crash, it was an airburst. In 1958, a new generation of researchers, led by Kirill Florensky, returned to the taiga with modern tools. Instead of looking for giant rocks, they looked for the microscopic. They began sifting through the soil and the layers of peat that dated back to 1908. What they found were tiny, glassy spheres, silicate and magnetite spherules. These were the frozen droplets of a cosmic body that had been vaporized by intense heat. Analysis of these spherules suggested something fascinating. They contained high concentrations of iridium and nickel, elements rare in the Earth's crust but common in space. The ghost was finally beginning to take a physical shape. It wasn't a single hammer blow to the Earth, it was a pressurized explosion in the sky that had acted like a gargantuan blowtorch, incinerating the forest from above before the shockwave flattened it. However, as the data grew, so did the mystery. If it was a stony asteroid, why were there no large fragments? If it was a comet, a dirty snowball of ice and dust, would it have survived long enough in the atmosphere to reach such a low altitude before exploding? The taiga was yielding its secrets slowly, and for every answer, a new, more bizarre theory was born. By the 1960s and 70s, the Tunguska site had become a holy grail for scientists of all stripes. The Soviet Union, now a spacefaring superpower, viewed the event not just as a geological curiosity, but as a preview of the dangers lurking in the cosmos. New expeditions, equipped with helicopters and sophisticated chemical sensors, began to treat the 2,000 square kilometers of flattened larch as a massive, open-air laboratory. One of the most striking discoveries made during this era involved the trees themselves. Biologists noticed that the trees that had survived the blast on the periphery, as well as the new growth in the epicenter, were growing at an accelerated, almost unnatural rate. Cross-sections of the wood revealed wide, healthy rings starting exactly in 1908. This led to wild speculation: was it the result of cosmic fertilization from rare minerals, or something more mutagenic? As the Cold War intensified, so did the fringe theories. In 1946, the Soviet engineer and science fiction author Alexander Kazantsev had published a story suggesting that Tunguska was actually the crash of a nuclear-powered extraterrestrial spacecraft. While this was dismissed by mainstream science, the idea took root in the public imagination. Enthusiasts searched for technogenic debris or radioactive traces. They found neither, but the search led to even more rigorous testing of the soil. The real breakthrough came from the mud. Researchers began taking core samples from the bottom of Lake Cheko, a small, bowl-shaped lake about 8 kilometers from the epicenter. Some scientists, even to this day, argue that Lake Cheko is the missing crater, formed by a single, solid fragment of the bolide that survived the airburst and hit the ground. However, sediment dating has remained controversial, with many geologists insisting the lake is much older than the 1908 event. While the spaceship theories faded into the realm of pulp fiction, the comet versus asteroid debate reached a fever pitch. If the object was a comet, it would have been composed mostly of ice and dust. This would explain why no large fragments were found. The visitor simply turned into steam and fine dust in a matter of seconds. However, computer models began to suggest that a comet would have disintegrated much higher in the atmosphere. To reach an altitude of 5 to 10 kilometers before exploding, the object needed the structural integrity of stone. In the late 1980s, Gennady Kasatkin and other researchers discovered something tucked away in the peat bogs: microscopic diamonds. These weren't the kind found in jewelry, but nanodiamonds, formed under the immense pressure and heat of a high-energy impact. These tiny crystals, along with high concentrations of the element iridium, pointed squarely back at a celestial origin. The Tunguska event was no longer just a Russian mystery, it was a global warning. It proved that the atmosphere is a shield, but even a shield can be hit so hard that the shockwave underneath it can erase a city. If the Tunguska bolide had entered the atmosphere just 4 hours and 47 minutes later, the rotation of the Earth would have placed the city of St. Petersburg directly under the blast. The course of human history would have been incinerated in a single morning. As the 20th century drew to a close, the focus shifted from "what happened" to "when will it happen again?" The trees of the taiga were growing back, covering the scars of 1908 with a thick blanket of green, but the data collected from their broken ancestors was now being fed into the world's most powerful supercomputers to predict the next great fire. The dawn of the 21st century brought with it a level of technological clarity that Leonid Kulik could only have dreamed of. Using satellite imagery and supercomputer simulations, scientists were finally able to reconstruct the Tunguska intruder with chilling precision. The consensus shifted toward a stony asteroid, roughly 50 to 60 meters in diameter, about the size of a 20-story building, screaming through the atmosphere at 54,000 kilometers per hour. The mystery of the missing crater was solved not by finding a hole, but by understanding the physics of a Mach disk. As the asteroid compressed the air in front of it, it created a cushion of plasma so dense that the asteroid eventually flattened and pancaked, exploding with the force of a massive thermonuclear device. The butterfly pattern of the trees was the literal fingerprint of this atmospheric hammer, showing exactly how the shockwave had wrapped around the curvature of the Earth. The Tunguska event transitioned from a historical curiosity to a modern mandate. In 2013, the world received a startling wake-up call that echoed the 1908 disaster, the Chelyabinsk meteor. Though much smaller than the Tunguska bolide, the Chelyabinsk airburst shattered windows and injured over 1,000 people in Russia. It was a mini Tunguska, caught on thousands of dashboard cameras, proving that these events were not once-in-a-million-year anomalies, but part of a cosmic cycle. Today, the site of the explosion is part of the Tunguska Nature Reserve. It is a place of profound, eerie beauty. Most of the original fallen trees have rotted away, returned to the earth to nourish the thick new growth of the taiga. Yet, if you trek deep enough into the marshes, you can still find the bleached bones of the forest, silvered, barkless trunks of larch that still lie in the same direction they were thrown over a century ago. The legacy of Tunguska lives on in the International Asteroid Day, held every June 30th to commemorate the anniversary of the blast. It serves as a global reminder of our planet's vulnerability. We now have the SpaceGuard surveys and infrared telescopes like NEOWISE, which scan the darkness for near-Earth objects, NEOs. We study the mud of the Podkamennaya Tunguska to ensure that the next time the sky splits open, we won't be caught watching from a porch in a remote trading post, but will be ready to deflect the fire. The story of Tunguska is a testament to human perseverance. It began with the terrified prayers of the Evenki, continued with the obsessive digging of Leonid Kulik in the frozen mud, and evolved into a cornerstone of modern planetary science. The Siberian taiga has largely healed its wounds, covering the scar with a sea of green, but the lessons carved into the earth that morning remain. We are part of a celestial neighborhood, and the day the sky shattered was the universe's way of reminding us that the stars do not always stay in their places.